Figure 6.23, Overloaded Square Functions. The concept of function overloading in C++ allows you to create as many functions with the same name as you like, as long as their signatures are different. And the signature of a function consists of the name of the function and its parameter list, not the return type, just the name of the function and its parameter list. So in this case, the signature of our square function at line 8 differs from the signature of our square function at line 15 because the one at line 8 expects to receive an int parameter and the one at line 15 expects to receive a double parameter. So there are several ways in which the signatures of functions can differ. One is, of course, that the names of the functions can be different. So we could have called these square of integer and square of double, and that would have made them physically different functions, different names, and therefore different signatures. On the other hand, another way in C++ to differentiate between functions that have the same name is based on the numbers of arguments, the numbers of parameters specified for those functions, and separately, if they have the same number of parameters, the types of those parameters. So for example, in this case we have, again, the one that receives an int versus the one that receives a double. As long as those signatures differ, the compiler can tell the difference between the functions, and the way it does that is with a concept behind the scenes called name decoration or name mangling. And effectively what we get is a logical name, if you will, for the square function, which is something like square of integer versus square of double. And if I had a function that received an integer and a string, it would be square of int and string. And if I had a function that received a double and a string, it would be square of double and string. Those are not the actual names that are being used, but behind the scenes, effectively, that is what's happening. The names are getting encoded to indicate what the function name is, plus a sequence of special characters that help the compiler understand what the types and order of the types of the parameters are. And that way, when we make a actual function call, like line 23, it's going to also mangle the calls the same way, or decorate the calls the same way, and then the linker will link up the call to the definition and allow us to invoke the functions in our program. And this is quite handy when you have similar or identical tasks that you wish to perform for either different types of arguments or different numbers of arguments as well. So to prove to you that this concept works, what we've done here is defined a square function that receives an integer, and it displays the value of the integer that it receives, indicating that we're calling for the square of an integer, and then it returns that squared value. And separately, we have a square function that receives a double, displays the value of that double, and we have this string here to prove to you which version of the function is getting called, and then we return the square of that number. Now, if we go ahead and run this program, actually before we run it, take a look at the two calls in main. The first one has the integer value 7 as its argument, and that integer value is going to result in a call to the version of the function that expects an int, and the second one is going to result in a call to the version of the function that expects a double. And if we go ahead and run this program, you can see clearly that in the first case we called the square of integer function with 7 as an argument and got back 49, and in the second case we called the square of double function with 7.5 and got back 56.25. And another way that we can look at this as well is, what would happen if we didn't have the int version of this function. So let's go ahead and comment that out for a second. Okay, so now we've commented out our square of int function, and now when we run the program, after it compiles here, you can see that in both cases the square function that receives a double argument got called. In the first case, it still received the integer 7 and gave us back the value 49. Remember, I mentioned in an earlier lesson that C++ does not display trailing zeros, so this is really 49.0 that was returned to us, but it doesn't display that unless you force it to display a decimal point with the fixed stream manipulator. And of course, we got the same value as previously for 56.25 when we squared 7.5. Now, again, the compiler is looking at the argument types and at the function definitions to figure out which function, which function to call in each case. And based on the fact that the parameter lists differ, it is able to separately pass 7 to the integer version of the function and 7.5 to the double version of the function. Now, this concept of function overloading is used frequently, especially inside of class definitions. It's very common, for example, to have overloaded constructor functions inside of a class that allow you to initialize objects of a class several different ways, and sometimes you'll even have overloaded versions of other member functions as well. So this is a big difference for those of you who are coming from, say, the C programming language, where we would get a compilation error if we were to define more than one function that has exactly the same name. And this is actually also something that can prevent a C program from interacting properly with a C++ program and vice versa, because in C we don't have this concept of name mangling or name decoration for function definitions. In C++ we do. So anything that we define in C++ that might have the need to be called from a C program has to be told not to have its name get mangled, and there is a way to do that using a special declaration called an extern C declaration. And basically what that does is it says we expect to use some name externally in a C program, and therefore we shouldn't mangle the names of the functions or variables, whatever they happen to be. So in C++, by default, every single function definition you create, whether it's part of a class or just a standalone function, every single one of them gets mangled to include the name of the function and an encoding that specifies the parameter list. And every single function call also gets mangled the same exact way, and then the linker's job is to link up those calls with their definitions. Now, when we hid the value, or when we commented out rather, this square function that took an integer, we were still able to pass 7 into the square function and have this double version get called. And the reason for that is when the compiler is compiling the square call, if it sees that there's no definition of a function that expects an integer, it looks for a definition of a square function that expects something that an integer can be converted to. So you may recall the promotion hierarchy that I showed you at the beginning of this lesson. An int can always be promoted or coerced to become a double value, because a double is capable of representing all the values that can be represented by type int. So when we do pass 7 to square and we only have the double version of the function, what happens is it converts 7 to 7.0, assigns it to the variable y, and then uses that in the function square.